standards. So worked on VP8 and VP9 for the video codec side, WebP on the image format side, and now one of the founding members for the Alliance for Open Media. We're going to jump into a little bit of what's gone on from the last year since we started the Alliance. But I wanted to start off by talking a little bit about how Google got to a place where it's very involved in open compression standards. It's not an immediate jump from sort of like the mission of the company and all that jazz. So really just trying to understand a little bit of the why here, of how we ended up in a world where Google cares about this stuff. And that's really trying to understand about the nature of the extent of data that we're working with. So Google has a lot of approaches or a lot of places that touch lots of video data, the biggest one being YouTube, of course. And I try to figure out if there's a way to get a handle on the scale of this using public data. And so I think publicly we talked about YouTube getting 400 or so hours of content uploaded every minute. And that's actually an old number. It's gone up a good bit since then, but that's what's publicly out since last year. And so if this sort of big white rectangle is your minute of time that you have to do your encoding and try to approach that problem, then that starts to look like the data that you're trying to address. That's the amount of content that you're getting in, which, to be honest, was less than I expected, just visually. Just trying to, more of a visual learner, and I looked at it and I was like, okay, like we can see the white rectangle still. It's like not out of the realm of possibility. But then, of course, there's actually the video that's being viewed. And unfortunately, I don't think we have recent public numbers for that. But you can imagine that you're talking about a similar jump in scale, and that's where things really start to break down, right? Because now you're getting to a point where that rectangle, the tiny white dot in there, is not to scale. You actually wouldn't be able to see it. It would be sub-pixel size. And so that's where we start to get to really big numbers. And of course, the talk we just heard and everything that's happened in the last couple weeks, it's been a big couple weeks for VR. So from the compression standpoint, that sort of just means it gets worse story. So obviously a lot of announcements from our friends up the road at Facebook, at OC3. Daydream announcing its products, and then 30 minutes ago, Andrew talking about the amount of content we're going to be getting. So this is a constantly evolving space. The decks have to update as well. And really this leaves us with a couple options, right? We can try to increase the amount of workable bandwidth that we have, really try to expand the internet, as it were, or make better use of the resources we have. And it's thankfully not an either or. So surprise, surprise, Google's working on both. Obviously, work in fiber is sort of one of the really public ways in which we're trying to improve bandwidth overall and give ourselves a little bit more to work with, reduce the chances of breaking the web. But there's obviously a lot of challenges of doing this type of work. It's expensive, it's hard, it involves a lot of capital expenditure and working with all sorts of parties. And ultimately, you end up in a situation where you're trying to do it in a place like this. So this is actually a photo that just got posted on Reddit a couple days ago. It's an aerial shot of New Delhi. So that's a city. Those are houses. Just an insane scale of population density. And you can only imagine the nightmare of trying to do fiber-type rollouts in a place like that. It becomes considerably more difficult. New Delhi is not on the list of cities that fiber is targeting anytime soon. I think I can safely say that without having talked to the fiber team about it. And so the challenges with increasing bandwidth are fundamentally there the minute you start looking at not even the long tail, really the bulk of what we're trying to address in terms of the world's web capacity and bandwidth. And again, this is the story here is this problem becomes worse the more cool things that we do, right? And so we're constantly bringing more people onto the web. Pretty much every tech giant at this point has their outlandish scheme to increase the amount of coverage for the web, whether it's balloons or planes or satellites. I think Google at this point is doing all three at once. And so this is a situation where you're constantly getting more people who are trying to use these services, and you're fundamentally getting them on the network, but sort of with the worst bandwidth possible, and sort of numbers that we've seen from a decade ago or more. So again, it ultimately comes back to this situation, right? And I think one of the other considerations about this sort of where to spend effort in terms of increasing bandwidth or doing a better job with compressing content, is that ultimately compression is a more scalable process, right? Even in the hardware space, as sort of chipsets upgrade and are able to take advantage of whatever version or rate of change Moore's law is at currently, or take advantage of hardware acceleration, ultimately those benefits do end up spilling roughly globally. Turns out there aren't that many chipset manufacturers who operate at scale, and a lot of people are working from not that many companies, versus your bandwidth and upgrades happen sort of on a very case-by-case basis and are ultimately local. And so that brings us to ultimately the answer for the why. It turns out this is the way forward to make sure the web works and does all the cool things we want. No real surprises there. So the question is, why does Google actually act in this space, right? I mean, the status quo has worked for a while. What's fundamentally changed? And I think just this actually is a little bit that I think Brian covered earlier. A lot of good things have happened with sort of the existing standards process, right? So sort of familiar list of error messages. I think we saw this from the other side. We saw this from the sort of content provider side. This is sort of from the user side. It just keeps going, right? I mean, it's a really nasty space of errors that we've actually managed to largely get away from in terms of how many users see this on a regular basis. And I think we can safely say that we have 264 and sort of the standardization process and the unifying process that came with 264 to thank for that. There are fundamentally great things that happen with interoperability, and so that is definitely a positive we can take from everything that's happened in the last couple decades of video infrastructure development. There are obviously some downsides as well. So royalties bring up a few different factors. I think we've heard a little bit about them today. Fundamentally, I think there's just the scale of time that we've seen from that process that's not fundamentally tied to royalties, just the broadcast hardware cycle has historically been operating at like roughly a decade, and that's sort of been the time period for hardware to update. And that's not fundamentally tied to how the web ends up developing and the web's rate of development. So there's a disconnect there between what historically has come out of MPEG and the rate of development there. But I don't think that necessarily is a reason to say that couldn't change or that couldn't speed up. But there are some sort of more fundamental aspects of how the status quo works that slow things down, right? Or make things more difficult in other ways. The first one just being that royalties are a different incentive structure for development. Fundamentally, if you're trying to create a new set of algorithms and a set of code that allows for better compression, if your incentive is to get your piece of code in for a financial incentive, that's a little bit different than trying to do so purely for technology gains. And I think the MPEG standards have managed to address that in many ways, but it's time consuming. It requires a lot of consensus and a lot of double checks and balances in order to prevent sort of financial incentives from corrupting what you finally end up developing. So that's sort of one problem just across the top. And ultimately, I think what we've seen that is it manifests itself in a slower process, right? The negotiation period for royalties after development period can take quite a while. There's also sort of the challenge of allowing for web development, which we'll see in a little bit, right? Royalties do play a part in sort of limiting a lot of the types of projects, sort of like the Internet Archive projects we saw today. You kind of have to work around rather than work with, and that's fundamentally not something that we're trying to do. And then really there's the uncertainty problem, and I think this is something pretty much everyone in the room is familiar with in terms of the availability of HEVC, the sort of looming possibility of some sort of patent pool around Dash. I mean, there's a lot of places where there are challenges to existing infrastructure or future infrastructure based on royalties. And so we don't think that's how the web has been working. And I think just to point to a specific example, the Visor folks were working on sort of a mirroring app that allowed you to remote into your Android device via Chrome extension. So it was a pretty lightweight, I think it was a one-person project, not totally sure. And ultimately it was something that rolled out for free, ended up using a 264 decoder that was packaged in with it. Sure enough, included a letter from MPEG-LA a few months after it was started. So a few months ago, rather. I think the app briefly had to be taken down in order to address those concerns. And ultimately, there were workarounds, right? There was the ability to take advantage of 264 decoders packaged within Chrome. There's the fees that were paid for by Cisco. There's a lot of things that the system has done in order to try to adapt. But as we'll see, that's not necessarily guaranteed in the royalty-based approach, right? A lot of things had to happen, some of which we think may have been related to our work, that led to a situation where even the current solution was possible, taking advantage of a 264 decoder. And of course, that solution does not scale over to using the newest technology and taking advantage of HEVC, right? And so the type of web development that we're all familiar with and the type of web development that Google would like to make sure keeps happening is not really compatible with the current royalty structure. There's another part of this, which is the possibility of working with internet standards. And we kind of go back and forth on this a little bit. There are people who feel different viewpoints on this within the team, I think. I would say philosophically, Google as a company definitely aligns pretty well with web standards. I think we work with them a lot in a lot of different areas. For codec development specifically, I think we've seen some challenges. I think it's a little tricky to talk about IPR stuff in that format. Things are slower than we expected in some ways. But just wanted to give a shout out to them. We're certainly considering them as well as part of this space and as a group that similarly is trying to build something that's royalty-free and works well for everyone on the web. So that's why Google was pulled into this. Let's take a look at sort of what's actually been done. So the first part is sort of the counterbalance effect, right? So I'm going to go ahead and do some bad science that Steve would probably not be happy about. And that's OK, because I'm acknowledging it. That's the way I'm going to take it. And that's sort of just a little bit of correlation here, right? So in May of 2010, that's when Google had acquired Onto Technologies about 3 or 4 months before that, and went ahead and open sourced the work they currently had to create VP8. A few months after that, we saw a change in MPEG-LA's strategy for streaming royalties. So royalties assigned to streaming content on the web that was not subscription-based, that was declared free indefinitely, a position that had moved around a lot in sort of the months and maybe even years leading up to that. So again, one data point, can't prove anything. There's a lot of things in the ecosystem that probably led to that. But there's no doubt that having a viable alternative to H.264 appear in the marketplace without the royalties had to fundamentally change the strategy for MPEG-LA. And I think that's something that we're going to see consistently. And what that means is that just having these projects and having these efforts creates some benefit for the overall ecosystem even before the first bit is actually downloaded or there's any encoding happening. That said, there was a lot of encoding happening and a lot of usage. And so what has happened in the sort of 6 years since then is we've seen a fairly large set of adoption happening for VP8 and primarily for VP9. So looking at something like north of 2 billion places that can play back content between Chrome and Android and Firefox and Opera and a few other places, and sort of along the level of 200 million hardware decode instances. A lot of that being on mobile devices and TVs that have come out in just the last couple of years. So the numbers are starting to grow there, and there's sort of a viable ecosystem that's coming out, and we've definitely touched all aspects of the industry with that. But I think the real interesting thing is, going back to good science, what we've actually seen with some of the studies that we've been able to do with YouTube. Doing the side-by-side comparison with H.264 and VP9 to actually prove out the case that having a better codec actually leads to better results. I think this is something that some of the JW Player folks started to show in their work, which is great to see validated elsewhere. And that's a couple things. So that's seeing that your load time does in fact start to improve, and perhaps more importantly, the actual watch time measure overall by geography, so taken in total, also shows improvements. And shows improvements in the kind of countries that you'd expect really benefit, right? Now, thankfully, we're seeing rebuffers going down as well. So this isn't a case where your experience is getting bad and everything's just taking longer. I think we have enough measures to show that that's likely not the case, and that we're seeing some actual benefits for users. So all good things, and sort of proving out the case that a new codec is actually a good thing. So the real question, this has so far been a great presentation for Demuxed 2015. But the question is, what's actually happened in the last year since we've gotten a little bit more involved in this process of working with other people? So the Alliance for Open Media stuff, I think, happened a little bit organically. Obviously, we've been talking to other companies who do web development for quite a while. There were a number of concerns, I think, that came out of the HEVC licensing pool that ultimately kind of brought people together to talk a little bit more. And that ultimately led to the initial version of the Alliance. So we had the 7 companies join, say we want to work on something together, and then start to actually think about what that means. So first off, again, before anything really got developed, I think we started to see some of the ecosystem shifts happen again, right? So a few months after we made our announcement, HEVC Advance moved away from some of their streaming-based royalties. I think they were trying to discuss something along the lines of 0.5% of total royalty revenue from streaming, a pretty astronomical number. And again, there was a lot of folks who I think when they first announced that, in every part of different industries were saying that was a crazy number. So I don't want to attribute it to one source, but the correlation now has 2 data points, so we're going to keep rolling with that. In terms of what the Alliance had as initial goals, again, no real surprises here. A next generation codec for the web, open source and royalty free. We viewed next generation as ideally being a 50% improvement in compression efficiency over VP9. And having the additional goal and sort of the +1 from VP9 of being even more interoperable. I think we achieved more than maybe we expected in interoperability with an open source project in VP9 and libVPX that was sort of a solo company effort as much as we wanted people to join in. But I think we're targeting much better outcomes than that even from the outset by having an alliance of different companies working with it. And so in terms of what we would actually have to release, this time around we're focused on making sure that we have a full spec available hardware RTLs available for decode and encode shortly after bitstream is frozen, and conformance test streams to make sure that we are able to make good hardware that definitely decodes everything correctly from the first time around. In the year since, we've grown quite a bit. A number of companies have wanted to join. There's even more companies than the ones that are on this list who are interested in knowing more about what we're doing without officially joining and implementing our hardware decoders as soon as they're ready. And we went ahead and formed a baseline. So a few months ago, we started to do the first integration work of what a next generation codec could look like, pulled from VP9 with some bug fixes, some like low-hanging fruit that we knew should be immediately fixed, and talked to the Mozilla folks and the Cisco folks who had their projects, Dala and Thor, about integrating their loop filters and their perceptual quantizers, and really trying to get to a point where we had something shared as our starting point for a codec. Then we started doing working groups. So trying to tackle a few different areas in parallel. Obviously, the main working group, which isn't listed here, is just the actual codec development working group, which has been working for the last year. And I want to stress this is not meant to be reflective of the full list of use cases. We have a dedicated RTC group that's focused on that use case, but we are definitely trying to tackle some of the VR work that Andrew talked about in his last talk, as well as a number of other use cases. But the engagement with these groups has been really effective. I think we've seen a lot of folks having the opportunity to discuss the viability of hardware implementations while the codec's actually being developed instead of hitting it at the end. We've seen that we're able to handle multiple use cases at once, which means that the algorithm development isn't pigeonholed for a single use case. And what's not also what's listed here at the top with testing is that we've gotten a lot of content from a lot of different companies, right? The Netflix stuff is great, and then in addition to that, we end up having the YouTube content to work with, and Amazon's and a number of other companies that are contributing content, so that we really address a number of different use cases. So what does it look like today? Well, we're doing a little bit of work in terms of getting our code bases all lined up. So currently our process is intended to kind of go through a little bit of a multi-channel review, having a chance to talk to the hardware folks, having a chance to do IPR review before doing a full integration into the AOM code base. That said, we have a number of experiments that are working in the code base that are still going through that process, but we think look pretty promising. So we started running numbers with experiments turned on. Keep in mind that some of these experiments might end up getting changed or adjusted, or the code might get changed or adjusted based on going through the full process. But that said, sort of early returns of where we are right now are about 25 to 30% better than VP9. So this is, obviously we could spend a lot of time talking about how you get a number like this, and I will be the first person to say that we didn't spend as much rigor getting this number as we will when we actually are ready to freeze the bit stream. That said, we're looking at a number of different metrics, sort of traditional ones, PSNR, HVS, which I think is this is just sort of an example curve of one piece of content that we ran through as a test. But we're also obviously talking to our friends at Netflix who have been working on more perceptual metrics, trying to incorporate VMAF to a wider set of content than just a Netflix use case. So again, the advantage of having the alliance goes beyond, I think, just the pure algorithm development. It means that we have a little bit more collaboration in all the steps involved in codec development, and that includes the testing phase, that includes our hardware releases, et cetera. So with that, I just wanted to leave a slide to mention sort of ways to get involved. I think one thing that's worth noting is you don't have to join the Alliance for Open Media to be involved. We are, in fact, operating open source. And so there's like a quick contributor guide you can fill out and then start looking at the code, playing around with it, implementing yourself, see what looks good that way. And just a couple of quick notes on questions that people are probably going to have, but I didn't have time to write into the deck official answers. In terms of timeline, we're roughly targeting first half of 2017 as our time frame to close the bitstream. That, I think technically, we think that's a doable challenge based on where we are so far and the progress we've had. We had a few places where we had to learn how to work together. And so now that we've done some of that, we think there's an opportunity to move faster. That said, we've never completed a bitstream with this process before, so a lot can still happen in terms of what that final little bit looks like. The last 5% or 10% is always the hardest part. So we'll keep an eye on that timeline, but that's kind of what we're shooting for. And yeah, I'll leave it there and open it to questions.
Hi.
Sure, yeah.
So with AV1 pulling stuff from codecs like Thor and Dala, which are both really, really well-named codecs, has any work been done to make a better name than AV1?
Yeah. It's funny. So as product manager for this space, right? I mean, product manager is kind of a weird term and a weird position to have. One of the few things that everyone has agreed on is that it's my job to come up with a better name. And that has proven to be my largest challenge so far. So I'm still working on it. For a while, I had a bunch of names that would result in a 3-letter acronym for my name, so it was going to be the JAI codec. That didn't fly for a number of reasons. So I'm going to my second iteration here. So yeah, open ideas for sure. Still in the works as well. Yeah.
So you said that the codec is targeting being 50% better than VP9. And also that maybe it's going to be done by kind of the middle of next year. But it's already kind of, on target with HEVC, which is apparently a little better than VP9. What's going to be the gate? Are you going to be like, it's going to be done when it's 50% better than VP9, and if that takes until the end of the next year, it takes until the end of next year. That's how it is. Or is it going to be something where it's like, well, it's 35% better, and we're at the middle of next year, so yeah, this is good enough?
Yeah, I mean, it's a good question. I think the answer is really going to depend on, or maybe the way I'd phrase it is, I think we're definitely done once we feel like we've pulled in all the obvious places to work and the places that we feel confident make a lot of sense to pull in. I think if moving the timeline means that we're going to lose like an easy 5% that we can get in a couple months, I think we would wait a couple months and make sure to get the additional, even if it means going above 50%, right? So I think that is like sort of a general, the way I'd phrase it is, that was a number that I think most of the companies who were in the group agreed on was a good place at which it would make sense to do a full re-encode. If they were already using VP9 or another codec, it would be justifiable for them to jump. For a couple of companies, I think it's lower than that. And I think what you're going to find is that there's maybe some variation by use case about what that number actually means, right? So 50% for a YouTube or a Netflix use case might look different for the RTC case, and I think that's okay. It's kind of baked into that. So I hope that gives you an answer. I mean, there's a little bit of an it depends, but we're certainly aware of that. Yeah, I don't know if there was anyone else. Oh, yeah, go ahead.
Yeah, so you focused on this bit rate reduction, right? But that necessarily means this know that Google has tons of CPU power and like at Netflix, there are other players who just can't do that much CPU for live streams or for their content. So what is their benefit there?
Yeah, absolutely. So the question was just how we're thinking about the complexity trade-off for CPU along with bitrate savings. Forgot to mention that actually in the deck, so thanks for the reminder. We're targeting, and we'll see how this works out, about 50% increase in decoder complexity, and likely a usable version that gives us that 50% gain that's about 10x more complex in terms of encode. So maybe that gives you a framework for what we're thinking. Now, obviously, I don't think there's two parts to this. One is there's not just one setting for encode, right? So our hope is that there's a little bit of variation, and that the 50% is really sort of targeting the high end of bitrate savings, right? So there would be options to use the codec, I think, at a more usable rate of CPU consumption. The second part of that is, I think there are certainly use cases you can imagine where getting the largest bitrate saving isn't the most important, right? Like there are production cases that we don't really even tackle with AV1 as our primary use case because you can afford to have giant files, and the main goal is to making sure that your quality is pristine, and that makes a lot of sense. So there likely are going to be use cases where the complexity doesn't make sense. But we think for most of the places that we're looking at of sort of web-related use cases, I guess the way I'd put it is the CPU capability is likely to get there before the bandwidth capability. And AOM definitely, or AV1 is definitely being built for the future. It's this chance we have with interoperability. There's chaos in the codec world. There's an opportunity to really build something that people use. And so there's definitely a goal of ours to make sure we're building something that works for years to come. And so from that perspective, I think we're hoping the complexity tightness on the CPU side gets easier over time. Yeah,
I think we got to call it. Sorry,
okay.
Guys.
Yeah.
Sorry.
I think so. I'm around after you want to chat. So.
You'll be at beers, right?
Yeah, exactly.
There you go.
Thanks.